Hello and welcome back. Now we've implemented crouching, but there's just a couple of issues that we haven't yet addressed, and you may or may not have realized it, but let's take a look at this block here that's hovering in the air. Now if I try to run under it, you'll see that the head just barely hits the block. And you would think that if we're crouching, we should be able to move under it, but we can't. And the reason is because it's not the mesh that collides with the block, it's the collision capsule. And the capsule, which you can't see, stays the same size even when we crouch. So that's something that we're going to take care of in this video. So first, why don't we open up Shooter Character BP and take a look at our collision capsule. Select the capsule component. We can see it here. It is basically as tall as the character. Maybe not exactly, but basically. Now we can come down here and take a look at the rendering section, and we can uncheck hidden in game. This will allow us to see the capsule in the game. And here under shape, we can see the capsule half height is 88. That's half of the actual capsule's height. Now we can press play. I'm going to undock and dock the tab here next to default map so I can press play in here, and you'll see the capsule, and there it is colliding just barely with that block. So how are we going to get that capsule to scale when we're crouching? That's what we're going to do in this video. Okay, let's get started. Here we are in Shooter Character. Now I'm up here in the constructor for Shooter Character, and here is our socket offset. Now we're elevating our socket by 70 in the Z direction, and now that we're doing some cool things with the feet like turning in place, I'd like to lower this just a bit. So instead of elevating us by 70, why don't we just elevate by about say 45. Now we should be able to see the feet, and also we should be able to see the character when she crouches. Now, how are we going to change the capsule half height when we're crouching? I'd like to use interpolation to do that, and so I'm going to come into shooterCharacter.h and create a couple of variables. Let's go down to the bottom of our private section and let's create a float. And this float is going to be our current capsule half height. So let's make a float and call this current capsule half height. And we're going to update this every frame so we know what our current capsule half height is. So let's give this a comment and say current half height of the capsule. Now we're going to have a couple of floats for our capsule half height when we're standing versus when we're crouching. So let's make those. Let's say float standing capsule half height. And let's make another float called crouching capsule half height. Now these we can expose to blueprints. I'm going to give them U properties. I'm going to make these edit anywhere, blueprint read write, category, movement, and meta allow private access. So I'll copy this and use it for both of these new floats. And we can just briefly give these comments. For standing capsule half height, we'll say half height of the capsule when not crouching, because we may not just be standing, we may be running and so on. And this will be half height of the capsule when crouching. Now let's go ahead and set these to their default values in the constructor up here at the very top. And I'm going to say standing capsule half height. I'm going to set that to 88.f. As we saw in the blueprint, that was the capsule half height when we looked at it. Now for crouching capsule half height, I'm going to set this to about half. Let's make it 44.f. And of course we made this adjustable in blueprints so we can adjust this as we see fit. So how exactly are we going to change the capsule half height? Well, we're going to need a function, and since I want to interpolate this smoothly, we're going to make a function that we will call in tick that's going to interpolate. So let's go up to our protected section where we have our protected functions, and let's create a function. It's going to be a void function, and I'm going to call this interp capsule half height. And it's going to take a float called delta time since we're going to be interpolating. Now I'm going to go ahead and give this a comment and say interps capsule half height when crouching slash standing. So we can go ahead and give this a body. Okay, so here in interp capsule half height, we're going to want to interpolate the half height of the capsule. So we're going to have a local variable, it's going to be a float, and we're going to call this target capsule half height. I'm going to use braced initialization here, and we're going to set this based on whether or not we're crouching. So take a second to think about how we're going to set target capsule half height. You guessed it. We're going to say if be crouching, then that means we want our target capsule half height to be the crouching capsule half height. So we're going to say target capsule half height equals crouching capsule half height. And in the else case, that means we're not crouching. So we're going to set target capsule half height equal to standing capsule half height. So that way our local target capsule half height will have the correct value based on whether or not we're crouching. All that's left now is to go ahead and interpolate the capsule half height. So we're going to create a const float local variable called interp half height. And we're going to set this equal to the result of an interpolation using fmath. So we're going to say fmath, finterp2, that's the float interpolation function, and we need our current capsule half height. Now, since we need our current capsule half height, we're going to need access to the capsule component. Now, here in the Unreal Engine documentation, I have uCapsule component pulled up, and here's the include, it's components/capsulecomponent.h. So let's go ahead and include this in our shooterCharacter.cpp. So I'm going to scroll all the way up to the top and include the capsule component. Now I'm going to scroll back down and notice since I left the line unfinished, there's a little tiny red square here showing me there's an error in the code. So that tells me where I need to scroll back down. So here we are. Now, since I have access to the capsule component, I can get that for the current capsule half height. So that's the first argument here. So to get that, I'm going to call get capsule component, and from there I'm going to call get scaled capsule half height, and that's how we get the current capsule half height. Next we need our target, and that's going to be the target capsule half height variable that we created here in the function. So that's the next parameter. And then finally we need delta time. And the last one is the interp speed. I'm going to use 20.f and see how that works. So now that we have this interp half height, now we can set the capsule half height to this value. So let's go ahead and do that on the next line. So we're going to get capsule component, and from there we're going to call the function set capsule half height. And this simply takes a half height and another optional parameter update overlaps, and that's by default true. We can set that to true since we do want it to update overlaps as we're changing the capsule half height. So we're going to set this to interp half height. Simple as that. So since we have interp capsule half height, we can now call this in the tick function. So let's go to tick, and down here I'm going to make a comment saying interpolate the capsule half height based on crouching slash standing. And I'm going to call interp capsule half height and pass in delta time. So there we go. Let's give this a compile and see how it works. Okay, let's go back into the editor now and hit play. And I'm going to crouch and take a look. The capsule half height is now smaller and we can go beneath the obstacle. Now, you'll notice that the actual mesh is lower. In fact, everything that's attached to the capsule is lower. It's going to be adjusted along with that capsule half height. So you can see that the camera's location is lowering because the spring arm is attached to the center of the capsule as well. But they're lowering in a smooth, interpolating manner, so that's not too bad. We do, however, want to adjust for the mesh being so low. You don't want the mesh to be dipped down into the floor like this. So as we're changing the capsule half height, we actually need to change the elevation of the character mesh as well. So let's do that real quick. So here we are in Interp capsule half height. Now we have our Interp half height. That's what we're setting our capsule half height to. And we also have the current capsule half height before we set it. So what we can do is we can actually get the change in capsule half height before we set it. We can get that delta. So let's go ahead and go right in between our Interp half height and the setting of the capsule half height, and let's get the difference between the current capsule half height and the new capsule half height. We're going to say float delta capsule half height. And we're going to set this equal to the difference between the Interp half height and the current half height. So it's going to be Interp half height minus, and we're going to use this get capsule component, get scaled capsule half height. There we go. So now we have the difference in capsule half height. Now, if we're crouching, we're going from a higher capsule half height to a lower capsule half height. That means Interp half height minus the current half height is going to be a negative value. Now, if we're standing, then we're increasing the capsule half height. So the Interp half height minus the current capsule half height is going to be a positive value. So let's go ahead and put a comment here so we understand what's going on. We're going to say negative value if crouching, positive value if standing. Now, the way we need to adjust our mesh is such that when we're crouching, we want to elevate the mesh, we want it to go higher. And when we're standing, we want to lower the mesh, we want it to go lower according to our delta capsule half height. So what we're going to do is create an F vector and call this mesh offset and initialize this with 0.f for the x, 0.f for the y, and negative delta capsule half height for the z. Since the delta is going to be negative when we're crouching, we're going to negate that and make it positive so that we're elevating the mesh rather than sinking it down. And likewise, since delta is positive when we're standing, we're going to negate that and make it negative so that we sink the mesh, and this will counteract the mesh sinking and rising along with the capsule. Now, we don't need to change these local variables, so I'm going to make delta capsule half height const, and I'm going to make mesh offset const as well, just to make sure that we're const correct. And I'm going to use mesh offset to add a local offset to the mesh. So we're going to say get mesh, add local offset. This takes an F vector, and I'm going to use mesh offset. And we can leave the rest of the parameters at their default values. Let's go ahead and compile this and now see how it works. Okay, so we're back in the viewport. We're going to go ahead and try to crouch. And now our character is not sinking into the floor. But you may notice the character is slightly elevated a little too much. And I've taken a look into this and I've realized that these crouch animations are elevated a little bit too much. Now we can figure out how much by pressing play and shift to crouch, and then we can use shift F1 to get our mouse cursor back. But since shift is our crouch button, it's going to cause us to stop crouching. So we need to be standing when we hit shift F1 to get our mouse cursor back while we're shifting. Now we want our mouse cursor so we can go ahead and hit pause and then click on possess or eject player. This will cause us to eject so that we can no longer be possessing the player, and we can take a look at just how much we are elevated off the ground. Now, in order to figure out how much we need to offset this for our crouch animations, let's go ahead and click on our character, make sure we have the character itself selected, and here in the details panel, select the mesh. Here in the mesh, we can see our mesh location, and it has a relative mesh location of -44. Now, with our mesh selected, we can make sure snapping is not on, and we can drag the mesh down to where it's on the ground. And this way we can see just how much we want our mesh to be lowered. So it was at -44, and I lowered it to about -49. So in other words, we're lowering the mesh by roughly 5 or 6 units. That's how much we want to lower the mesh in the crouching animation. So we can go ahead and hit stop. Those changes will not take effect because the game was playing and we simply adjusted the mesh elevation during the game. So that change will be lost. But we know that we want our mesh to be lowered by about 5 units in the Z direction for our crouching animations. We can do that by opening our crouching animations. Let's start with crouch, idle, rifle, hip. And let's scrub all the way to the beginning to our first frame. And let's select our root bone. If we move our root bone, everything will move accordingly. And we can take our local location here. For the Z, we can set this to -5, and that will bring everything down by 5. Go ahead and press key to add a key for this. Then we can click Save. Now let's close that and open our crouch to stand rifle hip. Open that, scrub to the very beginning, and select the root bone, and for local location, set the Z to -5. Go ahead and add a key and save. Next, we'll do crouch walk backward rifle hip. Go ahead and do the same exact thing. Select the root, add -5 to the Z, and add a key. Save and close. And we'll do the same to crouch walk forward, crouch walk left, right, and then finally the stand to crouch. We'll do that to all of these. Okay, let's open a new viewport so we can get this in full screen. Alt-P to play, and let's go ahead and shift. And now we'll see that we're just about at the right elevation. And as we're walking on the ground. Now these can be adjusted as you need to. Okay, so let's go ahead and walk under the obstacle, and you'll see that we're able to clear it. And if we're standing, we are not able to clear it. So crouching is now allowing us to go under obstacles that we could otherwise not go under. Excellent. Now, before we wrap this up, I'm noticing one thing I don't like, and that's that we are skidding to a halt when we're crouching. Now, we did give ourselves a lower acceleration and a lower ground friction so that we can get this skidding to a halt effect, but I don't want this when we're crouching. I want our movement to be crisp when we're crouching because when we're sneaking around, we're not really moving fast enough to skid to a halt. So let's go ahead and go back into Visual Studio. And let's go ahead and go back to our crouch button pressed function. Now we're setting our max walk speed, and we're also going to want to make sure that we don't skid to a halt. And the easiest way to do that is by changing the ground friction for our movement component. Here I'm in shooter character BP, and I've selected the character movement component, and if I search in the details panel for friction, you'll see that we have this ground friction here. We're going to want to set this to a high value when we're crouching so that we don't skid to a halt. So here in crouch button pressed, we're going to set our ground friction to a different value based on whether or not we're crouching. Now the character movement component doesn't have a public setter for the ground friction, but the ground friction variable is public, so we're going to go ahead and access it and mutate it here. So we need a couple of member variables. We want our crouching ground friction and we want our base ground friction. So we're going to go into shooterCharacter.h and add a couple of private variables. Let's add a float called base ground friction. And let's add a float called crouching ground friction. And I'm going to make these edit anywhere, blueprint read write, category movement, and meta specifier allow private access equals true. So I'm going to copy those from crouching capsule half height. Now I'll give these comments really quickly. This will be ground friction while not crouching. And this one will be ground friction while crouching. And we'll give these default values in the constructor. So in shooterCharacter.cpp, we'll say base ground friction. And remember, we had a very low value, 2.f, and that's because we want to slide around and skid to a halt when we're running around. But when our character is crouching, our crouching ground friction should be a lot higher, something pretty high, something like 100.f, and that will ensure that we have no sliding whatsoever. So we're going to use these. Let's go back into crouch button pressed. And when we're crouching, we're going to get character movement and access the ground friction variable and set that equal to crouching ground friction. And we're going to do the same thing in the else case when we are not crouching, except we're going to set this equal to base ground friction instead. Okay, let's go ahead and compile this, test it, and wrap things up. Okay, so back in the editor, let's hit play, and we will crouch. And as we're crouching and we stop, we actually simply stop. We don't skid to a halt. But as we're running, we will skid to a halt, and that will allow our jog stop animations to play, so it's more appropriate. But since we don't have stopping animations for our crouching movement, we will actually just stop. Okay, that is going to conclude this video, and our next few videos are going to take care of a couple more movement animation features that we would like to add, and after that we're going to get into creating some more items such as ammo pickups, so stay tuned.